13.3 is about frequency in histograms. But before we do these notes, I just want to make sure your 13.2 worksheet, the answers are now published. So you can go and check your answers and see if you are on the right track. So make sure that you do check that worksheet. Okay. So just a quick review. I just want to bring your attention over here. This is a frequency chart, okay? And so when you look at a frequency chart, you're going to have tallies. And so notice that what this is talking about. A researcher conducted a survey to determine the favorite colors of 130 people. Tally marks are used at the right to show the data. So this is how they tallied their data. So which color received the most votes? That would be the color green. And if you notice over here to the side, I'm going to put how many tallies we have here. So this one was 19. Ooh, you can't really see that. Let me try that. Maybe red. 19. This one had 29. This one has 16, 37, 8, and 21. Okay, so green had the most votes. The color pink received 29 votes. And then how many more people voted for green than pink? That would be 8. Which two colors are closest in the number of votes they received? That would be red and blue. So again, we're going to be using charts like this for our frequency charts. Okay. And we're just going to look at, so we understand what frequency is. So maybe I'll just draw your attention here. So frequency is the number of times that the event occurs, okay? Frequency is the number of times that the event will occur. So if you look at this example right here, if 39 people vote for pizza and 28 people vote for hamburgers, the frequency of pizza is 39. The frequency of hamburgers is 28. So frequency is the number of times that event occurs or the number of times it was voted on. All right, so let's look at this next page here. Okay, so first thing is making a frequency table. So let's just look here. A frequency table groups a set of data values into intervals and then shows the frequency for each interval. Here is the key. The intervals do not overlap. They don't have any gaps, and they're usually of equal size. Okay, so here's what we have here. Here's an example of how you would make a frequency table. So we're talking about the number of home runs by batters in a local home run derby. They're listed below. What is a frequency table that represents the data? And they asked us to use, so our intervals are intervals of 5, okay? So if you notice here, my first interval goes from 1 to 5. So my next one would go from 6 to 10, 11 to 15, and then 16 to 20, okay? And so what I want you to notice in these intervals, notice there is no overlapping. I stop here at 5, I start here at 6. Stop at 10, start at 11, and so on. Okay, so there's that no overlapping. There are no gaps. So I go from 5 to 6, and then from 10 to 11, and so on. And they're of equal size. So 1 to 5 is equal to 6 to 10 is equal to 11 to 15, and so on. Okay, so now what we're doing, these numbers right here that are listed are the number of home runs by the batters. So we want to list how many times did the home runs 1 through 5 occur. 1 through 5. So if you look here, I see a 5, a 3, a 4, a 2. So it occurred 4 times. There are 4 data values in that interval. Okay, let's look at 6 through 10. So starting at 6, and then I see some 7s, I don't see any 8s. I see a 9 and I see a 10. And that occurred 1, 2, 3, 4, 5 times. There are 5 of those. All right, 11 through 15. Let's erase those. 11 through 15. So I don't see an 11. I see a 12, another 12, see a 14, and we see a 15. That occurred 4 times. And then 16 through 20, I see a 17 in that, and that's all I see. So there's only 1 of those in that interval. Okay, so now we have the intervals, we found how many times, or we found the frequency of each interval. And so now what we're going to do is we're going to make a frequency table with this. Okay, so notice on the frequency table, the left column is interval, the right column is frequency. So it will look like this. So when you make a frequency table, again, you're going to have the intervals, and that was 1 through 5, 6 through 10, 11 through 15, and 16 through 20. And then on the right side, we're going to list the number of times that frequency happened. So on the 1 through 5, it happened 4 times, or you could put a number 4. And then 5 times, 4 times, and then 1 time. Okay, so that's an example of a frequency table. So again, a frequency table, you have intervals, and the intervals need to be equal, not overlap, and no gap. And then on the right side, you're going to have the number of times that interval occurred. Okay, now the second piece to this is this histogram. So here's what a histogram is. Histogram is a graph that can display data from a frequency table. A histogram has 1 bar for each interval. The height of each bar shows the frequency of the interval it represents. There are no gaps between bars. So I want to point this out to you. In the past, in your math background, you have made things like this before, right? And this is called a bar graph. We are not making a bar graph. We want our intervals to be side by side. So this is an example of a histogram. So there is no gap between the bars for a histogram, okay? So let's look at this second example here. So here's what we have. The finishing times in seconds for a race are shown below. So right here, these are the seconds it took people to finish a race. What is a histogram that represents the data? So the first question is, which of the following sets of intervals could be used for a frequency table to represent the data? Okay, so here's one way to do an interval. I always look for the smallest number, and the smallest number I see is 80. And then I look for the largest number, and the largest number I see is 105. So we know our intervals need to include 80. So if you look at A, does this interval include the 80? It doesn't. So we can mark this one out, right? Okay, let's go here. Does this one include the 80? It does. All right, so let's go over here. Does this one include the 80? It does. Does this one include the 80? It does. Okay, so we're left with B, C, and D. Now, next thing, remember that there can't be any gaps. So I want to point something out to you. If you look here, if I go from 85 to 90, do I have a gap in between those intervals? Yeah, because where are 86, 87, and 88? Where would those go if they were on there, right? So C cannot work, okay? Now let's look at D. The issue with D, I see 85 and then I see 85 again. And that's a problem because that is an overlap, right? And I only would have it look like this So it would only overlap like this if I have decimals. And if I had decimals, then it could look like this, but I don't. Those are all whole numbers. So I know, so let's just double check here, 80 to 85, okay? Then I would go to 86 to 91. That's equal to the 80 to 85 interval. Then from 91, I go to 92, yep. Go down to 98. And does this one include 105? It does. And so my answer would be this B right here, okay? And so we're gonna use that to make our frequency table. So remember, these are our intervals, and we're gonna make a frequency table, okay? So let's just, before we do that, let's just look here at this list and see how many times 80 through 85 occurs. So let's start with this one, 80 through 85 occurs. So let's see here. I see an 80, 82, 83, I'm going all the way to 85. Is that it? I think so. So that one occurred 4 times. Let's go to 86 to 91. So 86, 87, don't see that. 88, don't see that. I see an 89, I see a 90, and I think that's all I see. So that interval occurred 3 times. Next interval, starting at 92. Do I see a 92? Nope. 93, 94, 95 I see, 96, 97. So I only see 2 data points in that interval. Okay, starting at 98, I do see a 98. I see a 99, no 100, 101, 102 I see, so that occurred 3 times. And then the only number I have left is 105, that occurred 1 time. So in our intervals, our frequency is 4, 3, 2, 3, 1. So let's turn this over. Okay, so we're gonna make so again, this is called a frequency table. So you know the vocab. So on the left side, remember on this side are my intervals and this is my frequency. So just in case you have forgotten, our intervals went from 80 to 85, 86 to 91, 92 to 97, 98 to 103, and 104 to 109. And then that frequency that we just found earlier on the other page was 4, 3, 2, 3, 1. Okay, now the histogram part. So we're going to draw the histogram. Here's the key to the histogram is you need to label your axes, okay? This side is always going to be frequency. My vertical axis is going to be frequency. Your x-axis, if you will vary based on what you're talking about. So in our case, our intervals we're talking about are our time. Okay, so here's our time intervals. And then we're just going to put our time in here. So this first interval was 80 to 85. Second one, 86 to 91. That's all you do. You just put your intervals in here. Oh, 103. That didn't stay for some reason. And then 104 to 109. Okay? And then on the right side, my frequency, the lowest was 1 and the highest was 4. So I'm just going to number these by 1s. And then we're going to draw our bars. So the 80 to 85 interval, that time occurred 4 times. So I'm going to draw a bar that goes up to the 4 and comes right back down. Okay? The 86 to 91 interval occurred 3 times. So again, there's no gaps. I'm just going over and drawing a bar connected. 92 to 97 occurred 2 times. 98 to 103 occurred 3 times. And then 104 to 109 occurred 1 time. And then we just shade them in. And there is our histogram. Okay? Now, histograms can be described by their shape. And here are the options. You can have a uniform shape. If they're uniform, the bars are roughly the same height. So it might look like this. Pretty much all the same height, okay? If it is symmetric, it's just like what that word means. Symmetric, if I take a vertical line and divide it into 2 parts, they are close to mirror images of each other. So it might look like this. So if I drew a vertical line through here, these 2 sides look almost like mirror images of one another. And then the last one, it's skewed if it has like one peak that's not in the center. So if I have like this, maybe, that would be an example of a skewed histogram. Okay, so uniform, symmetric, and skewed. Okay, so let's look at the next question. The following set of data shows the number of dollars Jay spent on lunch over the last 2 weeks. Make a histogram of the data. Is it uniform, symmetric, or skewed? Okay, so here's what we want to look at. We want to make sure that we have the intervals, which all the intervals are the same. The frequency is the same, 1 through 4. So we need to see which one makes sense, okay? So let's start with this 1 through 5 interval, because they're not all the same. So we need to see 1 through 5. How many times did the numbers 1 through 5 occur? So let's look here. So I see a 1. I don't see a 2. I don't see a 3. I see a 4. I see a 5. I see another 5. So this interval 1 through 5 occurred 4 times, right? Well, if I look here, I'm showing this bar only occurred 3 times. Well, that can't be right. This one only showed 2 times. So that can't be right. This one occurred 4 times. So this would be the correct histogram. And then circle the word that best describes the histogram. So what would best describe this one? So it's almost completely equal. And it's just roughly. It's not going to be exact. And so this would be an example of a uniform histogram. Okay? All right. The last piece of information for vocab that you need to know is this, what we call, a frequency table. A cumulative, sorry, you already know frequency table, cumulative frequency. Okay, so here's what I want to point out. Again, you still have your interval on the left. Then you have the frequency. The difference is the new piece is this cumulative frequency that you have on the right. Okay, so here's how it works. So I have this interval 0 to 5. We want to go up to our information and find how many times does that interval 0 to 5 occur. Okay, so we start at 0. I see a 0. I see a 1. I see a 2. No 3s, no 4s, and there's a 5. So that looks like it occurred 7 times. Okay, so I go over here and I put a 7. Now, let's do the 6 through 11. So I don't see a 6. I see a 7. I don't see an 8. I see a 9, a 10. I see an 11. That occurred 5 times, which that's already written. So now, if I would put a 5 here, well, I guess I don't need to do that. Now, cumulative means added up. So 7 plus 5 would be, now my cumulative frequency is 12. So the cumulative frequency of the first 2 columns is 12. Okay, let's look at this last column, 12 through 17. So I see a 12, 13, and then 15 twice. So this is a 4. So now if I add up all 3 of those, 7 plus 5 plus 4, right? That's going to be a 16. Okay, so your very last column in your cumulative frequency column should be the total of all of those added together. Okay? Okay. Last vocab right here. It says compare and contrast. So do we understand the following? So we want to, what's the difference between a symmetric histogram and a skewed? So we're talking about the difference between symmetric and skewed. Okay? Underline the correct word. If you can draw a vertical line to make 2 parts of the histogram that are mirror images. So remember, mirror images would be symmetric. If the bars are not roughly the same height and they are not symmetric, then it is skewed. Okay? Okay. That will conclude our 13.3 notes. If you have questions, put them on your discussion board or message me. Thanks.